Students, today we shall start one new chapter, that is factorization. Already you have read in class 7 what are the factors, and you have also read that whenever a composite number is there, then how can it be factorized, and also in case of prime number you can let it be an example of 5. So 5 can be 1 into 5. If you will be given a composite number, let it be 6. So 6 can be factorized 2 into 3 or 1 into 6. The factorization should be such that there would be no scope for further factorization. For example, I have told 1 into 6. If you will see this one, that will be wrong, because 6 is a number which can further be factorized. So at best you can say 1 into 2 into 3, like so. This is regarding factorization of the numerals. Whenever we have given algebraic expressions or algebraic terms, they can also be factorized, and the factorization should be such that it should be irreducible factor. So what does it mean? Irreducible, which cannot be further reduced. Very small example first I want to give you. Suppose one term has been given, that is 5x. So you see, if you will be asked factorize this one, means we can write 5 into x. So one thing, 5 is a prime number. It cannot be further reduced by the product of any other two numbers. Only 1 into 5 which cannot be taken into consideration. Suppose it is given 6x. One thing, 6 is your composite number. So 6 can be, that is 2 into 3 into x. Now we compare these two. It is given that algebraic equation can be expressed as the product of irreducible factors. Now 5x, 5 into x, this cannot be reduced into another smaller numbers so that whose product would be 5x. Similarly 6x, and because 6 is a composite number, so we have factorized this 6, 2 into 3 into x. This 2 into 3 into x, this is the factorization, and that cannot be reduced, that cannot be further reduced into smaller terms, this one. And irreducible, as I have already noted here, irreducible factors means factors which cannot be expressed as a product of the factors for further, that cannot be reduced. Now whenever we are going to discuss about more about the factorization, first I want to tell you factorization by taking common factors. First you should know what is common factor, then you can go for the taking common factors of algebraic equation. Common factors, for example, suppose I have written your 8 and another one is 12. These are the two numbers that I have written. So if I have factorized this one, this 8, what are the factors of 8? Now factors of 8 starting from 1, 2, 4 and 8 itself. What are the factors of 12? Now 1, 2, 3, 4, 6 and 12 itself. So one thing, if you see the factors of 8 and factors of your 12, which factors are common? Now your 2, 1 and 4. So whenever we are going to take common between two or more numbers or algebraic expressions, then we have to take the highest one. Suppose here the highest one is 4. that we have to take, common factor should be taken as 4. So let us first discuss the first one, which whenever it is given that factorizing by taking common factors. It is given that 24x cube minus 32x square. We are having two terms. One is your 24x cube and another one is your 32x square. So you see the numeral part of the terms, it is your 24 and here it is 32. So now you just find out which factor is the highest one in between factors of 24 and 32. That is nothing but 8. And I have already told you the highest factor should be taken. And now your literal part and numeral part factors that I have taken 8, because 24 is divisible by 8, 32 is also divisible by 8. There is no any other number more than your 8 which can divide, which is divisible by both the numbers. Go for the your literal part. You see here it is given x cube and here it is given x square. So whenever the in between these two, the highest exponent is 3 and your next one is 2. So whenever here we are having two exponential terms of the same variable, we have to take the lower one as the common. Lower one as the common. So we can take 8, this one, and lower exponent is 8x square. Okay. Now whenever 8 has been taken common, then what left here? Now 3, because 8 into 3 is equal to 24. Okay. And now we have taken x square. So from x cube, x square has been taken common. So that is only x. And here 32. So 32 means 4 will be left there. So minus 4. And no your literal term. So one thing you may ask, sir, where that x square has gone? Simply you say, simply you look here, we have taken x square as common. So only x square was there. So whenever we have taken common, so it's only 4. So means how? Now 8 into 4 is equal to 32. And whenever the highest common factor in between 24 and 32 that we have taken, so 4 has left. So now we have factorized this one. This is the factorization of this term. And one thing, this cannot be reduced more. This cannot be reduced more, or it is now in irreducible form. Second thing, by grouping terms. Now you see only two terms have been given, and we have taken the formula for taking out the common. So this is the answer. Whenever more than two terms, as here in this case, you see your ax plus by plus bx plus az plus ay plus bz. Now you see 1, 2, 3, 4, 5, 6. 6 terms have been given. So whenever 6 terms have been given and you want to factorize this by grouping them, two things that you have to take into consideration. Whether we can group them, we can make them two groups by taking 3 terms in each group, or we can make them 3 groups by taking 2 in each group. So here in this case, the first option cannot be taken because the terms are like so. If we group them 3 terms each, so there will be no any common among these three. So that is why we have to take two terms in each group. So here you see ax plus by, bx plus az, and ay plus bz. So before going for the taking, that is grouping them, you should not directly whatever the question is being given in group them. No. First you have to see, suppose the first term has been given x. So what should be taken with this term so that I can get a common? Here you see, here ax, here az, here your bx, like so. So you just have to look the terms again and again. Very minutely have to see what would be taken common, so that in each two, so that I can get the other part equal. As here in this case, you can say I have taken ax plus bx first, because I see x and x common. Thereafter, I can make your ay plus by, then your az plus bz. Now we have grouped them by keeping in the bracket. Okay, in the first group, what can be taken common? Now x, so whenever we shall take common, that would be a plus b. In the second one, we have to take common y, that would be a plus b. And here we can take z, that would be also a plus b. So very important thing here that you have to learn, that whenever you have taken common by making them group, so these parts should be equal. If not, then it is wrong. So before going to this one, you have to see whatever I shall have to take common, so that these three parts would be equal. And whenever a plus b, a plus b, a plus b. Now we shall take a plus b as common, because it is there here also and here also. And finally that would be x plus y plus z. This is the factorization. And whenever you are making them group, you have to very minutely see how can I arrange them. It is given in question is in this form. How can this question be rearranged, so that in this way we can take common, and we have to see that this part should be equal. If not, then again we have to go for any other option by the rearrangement. And finally this is this one. This is the second. And your third one is, it is given factorizing by identities. So one thing, algebraical identities, I think you might not have read, just like your a plus b whole square. What is this? Now it is a square plus 2ab plus b square. Similarly, a minus b whole square. Only for the sake of example, I have given these two, this one. So these algebraical identities are with us, and by taking the help of this, we shall have to factorize this one. You see, the question is 81x square minus 90xy plus 25y square. So very important thing, very important thing that I have to tell you, that you are in class 8. So these algebraical identities you should remember, so that factorization would be more easy. As here in this case, you see it is given 8x square. Thereafter your 81x square minus 90xy plus 25y square. So you just see both the extreme two terms, means 81x square and 25y square. 81 and 25 are perfect square number. Means square root of 81 is also that is your not in factorization, it is your integer, that is 9, and your 25 square root is 5. So now instead of writing 81 I can write 9 square and x square, and your x square means like so. So instead of writing this one 9 square and x square, I can write this one 9x whole square. Okay. Thereafter, keeping this blank, you can write it is 5y square. Now 2 into 9. Just to remember, I want to put this identity a minus whole square. 2 into 9, it is 18. 18 into 5, that's 90. 5 is given in this question. So we can write 2 into 9x into 5y. And you see, this has been factored and it is 90xy. So if we shall take 9x as a, so I can write it x square plus 5y as b, I can write it y square. So minus, instead of 9x I can write 2a, and instead of 5y I can write b. So now it has come in this a minus whole square formula. So we can write it 9x minus 5y whole square, and which can also be written 9x minus 5y into 9x minus 5y. By putting algebraical identities, it is easy. And the last one is factorizing trinomials. So this is also trinomial, and here whenever you are going to doing this trinomials, that is middle term factorization. Here you see your middle term is 11x. So we have to split this 11x in such a way so that if both will be multiplied, both the splitted term will be multiplied, that would be equal to the product of the two extreme terms. Our question is x square minus 11x plus 30, and we have to factorize this. Mostly it is known as the middle term factorization. This is the middle term, and you split 11x in such a way, if you multiply them, that would be 30x square, and if you add them, that would be minus 11x. So one thing, if 11x can be 5x plus minus 6x, this is also 11x. So 5 minus 5 into minus 6, it gives you plus 30. X into x, it gives you x square. So if you multiply the product of the two terms, it also gives you 30x square. So while you are splitting this middle term, you have to see that the product of the two middle terms, the splitted terms, should be equal to the product of the two extremes, and the sum of the splitted terms should be equal to the middle term with the sign itself, as here in this case. So now we can write x square minus 5x minus 6x plus 30, which can be your, now group them, x square minus 5x one group minus 6x minus 30 other group. So students, you see here it has been given plus sign, but I have marked it minus sign. You may ask me, sir, why? Because here there is no bracket, and whenever I have kept them these two terms in bracket, and before the bracket there is a minus sign, so I shall have to change this sign to minus sign. That is very important, that you have to mark. Many of the students are committing this type of mistake. So here common means only x can be taken common, x minus 5. Here you can take 6 common, x minus 5. Again the same thing. Whenever you are taking common, you should see both should be equal, otherwise that is wrong. Now again we can take x minus 5 common, and it gives us x minus 6. This is your factorization. So factorization itself is easy. We have to remember some algebraical identities, and also always you have to watch if we have been asked to take by taking common. So the highest number should be taken common in literal as well as in numerical terms, and in case of your factorization of trinomials, this should be C. Many more sums are there in your this factorization, and we shall discuss them more. And if you have any doubt, you can go to the comment box and give me necessary comments or suggestions so that I can clear your doubts. Thank you.